Welcome to the deep dive. We've got a listener facing a bit of a puzzle with their Tamiya Grasshopper II.
Yeah, seems like a classic RC head scratcher.
Totally. Their Lunchbox 18-tooth pinion gear, the Grubscrew, keeps loosening up,
Hmm.
but only when using the Tamiya 380 sport-tuned motor in the Grasshopper II.
And the weird part is, they say the same pinion is totally fine in their original Grasshopper.
Exactly. So our mission today, figure out why. What's different? What's causing this?
Okay, we dug into the technical sheets, compared the GH1 and GH2 chassis, the usual suspects, and looked at what other folks in the community found.
Good stuff. The idea is to unpack this specific problem, but hopefully give you some broader takeaways for any kind of mechanical troubleshooting.
Right, let's start with the parts involved. That 380 sport-tuned motor, it has a 2.3 millimeter shaft,
Okay.
but the Lunchbox pinion, that specific one, it's bored for a 3.17 millimeter shaft. Standard 540 size, basically.
Ah, okay. So straight away, they don't fit. You need something in between.
Precisely. You need that little adapter sleeve. And honestly, that adapter, that's probably ground zero for the issue.
How so?
Well, think about it. Instead of the grub screw biting directly onto the motor shaft,
Yeah.
it's tightening onto the sleeve. And the sleeve is just pressed onto the shaft.
Yeah.
So you've got, like, two potential places for slippage now.
Ah, shaft to sleeve and sleeve to pinion. Gotcha.
And that motor shaft, the 2.3 mil one, probably doesn't have a flat spot machined onto it, right?
Likely not, no. They often don't on the smaller motors.
So the grub screw, even clamping through the sleeve, is basically just pressing onto a round surface, not nearly as secure as clamping onto a proper flat.
Right, like you'd usually get with a 540 motor shaft. That flat gives the screw something solid to lock against.
Exactly. It's just a fundamentally less secure connection using that adapter.
Okay, that makes sense. What else?
Then there's tolerance stack-up.
Tolerance stack up.
Yeah, tiny variations in manufacturing. The shaft might be fractionally under 2.3 millimeter, the sleeve's inner diameter slightly over, the outer slightly under, the pinion bore slightly over.
And all those tiny differences add up.
They can, yeah. It means the whole pinion assembly might not be perfectly centered on the shaft. Even a tiny bit off-center causes vibration when it spins fast.
And that 380 sport tuned is definitely faster than the stock 380 motor it replaces. More power, more RPMs.
Absolutely, way more power, which means more vibration just from the motor itself. And vibration is like the natural enemy of grub screws.
Okay, so the adapter makes a weak link, and the stronger motor shakes it harder.
You got it. Plus, more torque puts more sudden stress on that connection every time you accelerate.
So why doesn't the original Grasshopper have this problem, even with maybe the same pinion, perhaps on a 540?
Ah, good question. This is where the chassis design really comes into it. The Grasshopper II, it uses that rear suspension design borrowed from the Hornet.
Right, the pivoting gearbox setup.
Yeah, and it's known for, well, hopping, especially with a hotter motor. The whole gearbox can kind of lift and twist under power.
Okay.
The original Grasshopper has a much simpler rear end. Solid axle housing, more rigid, less prone to that kind of dynamic movement.
So the GH2's bouncy rear end is literally shaking the motor and pinion assembly more vigorously than the GH1 would.
That's a big part of it, yeah. That instability puts extra stress and vibration right where that weak adapter connection is.
And maybe the motor mount itself plays a role.
Could be. The GH2's motor mount is sort of integrated into the gearbox casing more directly. The GH1 often had a separate motor plate. Maybe, just maybe, that separate plate dampens some vibration slightly better than the GH2's setup. It's subtle, but possible.
So system dynamics, the whole car's behavior matters.
Definitely. And back to that adapter sleeve. If it's not perfectly centered, remember the tolerance stack up. That can mess with the gear mesh too. As the pinion spins, it might engage slightly differently with the spur gear throughout its rotation. More unevenness, more vibration.
Ugh, it's like a cascade effect. The adapter causes vibration, which loosens the screw, and the adapter might also cause bad mesh, which adds more vibration.
Pretty much sums it up. A direct fit pinion, like you'd probably have in the GH1 with a 540, is just inherently more stable, better connection, likely better mesh stability.
Okay, so it sounds like a combination of factors all pointing back to that adapter being used with a more powerful motor and a more lively chassis.
That's the core of it.
So what can our listener actually do about it? Let's get practical.
Right. Solutions. First things first. Basics. Clean everything really well. Degrease the motor shaft, the inside and outside of the adapter, the pinion bore, and the grub screw itself. Any oil makes it easier to slip.
Good point. Then tightening.
Yep. Use good quality hex driver, not a worn out one. Make sure it fits the screw properly. Get it snug, but don't strip it. And crucially, use the thread locker.
blue Loctite or something similar.
Exactly. Blue, medium strength. Like Loctite 243 or Tamiya's own blue thread lock. Just a small drop in the screw hole before you tighten it. It fills the gaps and stops vibration loosening it.
Okay, clean, tighten properly, use blue thread lock. What else?
The biggest help would probably be creating a small flat spot on that 2.3 mm motor shaft right where the grub screw hits.
Ah, yeah, file a little flat.
Gently, yeah. Use a small file or a Dremel tool carefully. Just a small flat gives the screw a much better surface to bite into. Makes a huge difference.
That seems key if you're sticking with that motor and adapter.
Definitely. Also, check the grub screw itself.
Yeah.
Is the hex socket rounded? Is the tip damaged? Maybe try a new grub screw. They're cheap. Same for the pinion, any visible wear.
Worth checking.
Yeah.
And the ideal world solution.
Ideal. Find an 18-tooth pinion that actually has a 2.3 mm bore. No adapter needed. They might be harder to find, but that eliminates the whole problem at the source.
Or, I suppose, go back to a standard 540 motor. Though that might need mods to fit the GH2 gearbox, maybe.
Potentially, yeah. Or maybe look into an adjustable motor mount if one exists for the GH2. That could help fine-tune the mesh. But the flat spot and thread locker are the main things to try first with the current setup.
Okay, so wrapping this up. The loose screw on the GH2 isn't just one thing, it's the adapter creating a less secure fit, combined with the extra vibration and power from the sport-tuned motor, all amplified by the, let's say, active dynamics of the Grasshopper II chassis.
That nails it. The original Grasshopper with a direct fit pinion just sidesteps most of those issues.
It really shows how these seemingly small interface choices, like needing an adapter, can interact with the whole system's behavior, doesn't it?
It really does. Makes you think, you know? What other little mechanical compromises or unexpected dynamic interactions are happening in machines all around us, causing problems we might not immediately understand? Something to chew on.